with doing this EEG data viewer. It's based on data from this Kaggle competition, harmful brain activity classification. Don't worry about the competition itself. Okay, so we are using the correct microphone. So currently, yeah, we have everything working except the spectrogram. So we'll be loading the spectrogram. The spectrogram is in the original data. So currently we're trying to use chart.js to plot the spectrogram, which is obviously not a great idea. So let's ask, I forgot what's called the Java library. What is the can chart.js plot the spectrograms? If not, what would be a better library to use? It should be a simple question for GitHub Copilot because it doesn't need the context of the whole thing. Spectrogram. Yeah, we have 4 spectrograms. Okay, apparently it was too difficult to answer for Copilot. Alright, Plotly. Yeah, that's the one we want to use. Yeah, we had a sample code. Let's shut the Flask application for a second. So making a Flask application. And we had this test chart.js to plot the spectrogram. Actually showing something useful. Sorry, that was a HTML file. So it looked like this. It's kind of okay, not quite, but okay. But yes, we essentially weren't able to replicate this for the spectrogram. Unfortunately, why my camera is frozen. Should be better. I don't know. There's 2 cameras I have connected via USB. It's probably what happens when you connect Microsoft gear. Well, I mean, they're not making any gear. They labeled Microsoft webcam to a Linux machine. Not a good idea. Right, so we had this example in HTML. I forget how we already have a tool on bionichaos.com. By the way, if you haven't checked bionichaos.com yet, please go do so. But this tool that does show EEG spectrograms, that is using a Plotly. So it's working fine. So in this case, we're meant to have 4 of those for different positions on the brain. Left lateral, right lateral, left parasagittal, and right parasagittal. Sorry for mispronouncing this word. Hopefully you're not an expert. If you are an expert, do let me know. I would like to collaborate. Spectrograms. And then we have frequencies for them. So they're kind of low res. There shouldn't be too many of them in the data. And they're meant to be they're all 10-minute long. Yeah, spectrogram of a 10-minute window. And we have the frequency in hertz. So we're not passing that data correctly at the moment. Okay, so a couple of issues. The spectrograms are loading forever and eventually give an error. So even if I try to load just one spectrogram instead of the all four that we have, what's happening is, yeah, the plotting is not correct. I'm wondering if the data being parsed correctly or not. Can we actually check the relevant part of the code for this and update it? A worst case, we'll need to move to using Plotly.js to display the spectrograms correctly. Let's pop it into both boards. Yeah, we have full disclaimer. We have the bots doing everything for us. We can't code. And yes, it's also co-hosting the YouTube channel. So hopefully it can tell you some jokes, relevant jokes, not like ha 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 jokes. Let's read this one because I've been talking enough already.
Got it. Let's narrow down the issue with the spectrogram loading and plotting. To do this, let's focus on two main areas. One, data verification. Check if the spectrogram data fetched from the backend is correctly formatted and valid for plotting. There might be issues with the data structure, data types, or the presence of unexpected values like nan, null, or infinity. Two, chart rendering. Ensure that the data is being correctly passed to the chart rendering function and that chart.js or any other library you might use can handle this data format efficiently. Here's a step-by-step approach. Check data structure and integrity. Log the data. In your fetch and display spectrogram function, right after you receive the data from the backend, log it to the console. This way, you can visually inspect the data structure. Data format. Ensure the data is in a format that your plotting library can handle. For spectrograms, this typically means arrays of numbers, possibly organized by frequency bands or time steps. Validate the chart rendering process. Chart data preparation. In Get Chart Data for Side, check how the data is being prepared for the chart. Make sure the data sets are correctly constructed with appropriate labels and data points. Error handling. Add more robust error handling around the chart rendering code. Catch any errors and log them to see if the rendering process itself is failing. Simplify the plot. As a test, try rendering a very simplified version of the spectrogram with hard-coded minimal data. If this works, the issue might be with the actual data being passed. Considerations for moving to Plotly.js. Complexity of spectrograms. If Chart.js struggles with the complexity or size of spectrogram data, Plotly.js might be a better option. It's more powerful for handling complex and large datasets. Implementation. Switching to Plotly.js would mean adapting your data format to what Plotly expects and reworking the rendering logic. Plotly provides more flexibility and interactive features, which can be beneficial for EEG data visualization. Debugging steps. Isolate the issue. Try isolating the spectrogram rendering in a simple, separate HTML file. This helps to determine if the issue is within the chart rendering logic or somewhere else in your application. Browser tools. Use browser developer tools to monitor network responses, console logs, and potential JavaScript errors that might hint at what's going wrong. By going through these checks, you should be able to pinpoint whether the issue lies in data fetching, formatting, or in the rendering process. Once identified, you can decide whether to fix the existing implementation or switch to a more robust library like Plotly.js for your spectrograms.
Biased language saying Plotly is more robust, is it? That's good to know. So question is, should we continue with Chart.js or just move to Plotly straight away, considering we have this spectrogram working already? I mean, you can do heat maps with Chart.js, like you can see here. Yeah, what do you think? What do you think? By the way, only talking to a robot because we don't have a human on air. We're also using GitHub Copilot if it's easier for GPT-4 to provide prompts for GitHub Copilot to actually do the coding. That would be okay. Yeah, Copilot doesn't have the overall context. It's giving very narrow kind of responses. I don't understand why the data format between Chart.js and Plotly.js will be much different. Yeah, we could fix the current format. We have a get spectrogram site. No, that's spectrogram ID. We have the consensus options. That's are the different labels. We have the electrodes, patient IDs. Right, it's a very long list. That's the label for a current EEG ID. I have a spectrogram ID. What's that one? Those are the sub IDs with the offset time. That's okay. We explained this in previous streams, but that's pretty straightforward. Each label is for 50 seconds. And in this case, you have just over 100 seconds of data. So yes, it's not clear why you have 18 labels in there. I already complained about this in the past. So we leave it at that. Get label for specific ID is not working. So that's something we need to fix. Because each sub ID should have a label as well. So this will be something simple to start with. I have get the spectrogram patient ID. Yet this get label. We have a sub ID. Is it actually being used? Yes. Just need to make sure that in JavaScript we actually using the sub ID as well. Are we? I don't think so. Where's the response? Sweet. Data not found. Refuse to connect. Anyway, they have a problem with the spectrograms. Well, right, it's not running. The it's important when testing the application to actually run it. Yeah, every time I do this drop down, even if the Flask application is not running, it's loading forever. Close that one for a sec. Actually run the application. That would help. Right. Now the label is working. Okay. Yeah. Yeah, now it's actually populating okay as well. So the spectrograms are currently being displayed when we load a different sub ID. Yeah, so we get the plot. The plot is linear instead of it's called JavaScript. Yeah, I can close it. JavaScript with the chart. Have lots of charts. Got the bottom display chart for side. Get chart data. We have fetch and display spectrogram. We can get rid of that. Get spectrogram ID is working okay. I'm pretty sure. We will double check everything. Okay, what else? Yeah, so this bit, the canvas, create a chart and store it in the charges. Yeah, we have some trouble with those. Canvas ID, chart data, that's okay. We have destroy, it's fine, that's for replotting. Now this chart should not be linear, that's for sure. The other problem is time. Hopefully time is being passed correctly. I don't think so. We'll test it in a sec. Okay, can we focus on how the spectrograms are being charted? There's a couple of things that are obviously wrong. They should not be lines. They should be boxes of color with intensity. Yeah, you know what spectrograms are like, spectrograms. Yep. Yeah, let's see if I can get anything out of it. Sometimes refusing to, I don't know, I was just about to say, it's sometimes refusing to actually generate a code. Yeah, in this case, yeah, so it moved to using Plotly. It's kind of made that decision by itself. That's interesting.
I see what you're aiming for. Spectrograms are indeed more complex visualizations that typically require a display of color intensity over 2 dimensions, time and frequency, which differs from the line charts you're currently using. While Chart.js is versatile, it may not be the best fit for spectrograms, especially if you need to display them as color-coded heat maps. That's where plotly.js shines. Plotly.js can easily handle such complex data visualizations, including spectrograms. It offers features for creating 2D color maps where each cell's color represents an intensity value, which sounds like what you need for your EEG data. Here's a suggestion on how to proceed. 1. Switch to Plotly.js for spectrograms. Given the complexity and requirements of your spectrograms, Plotly.js would be more suitable. It's well equipped to handle heat maps and more complex visualizations that Chart.js may struggle with. 2. Adjusting data format. While switching to Plotly.js, you'll need to adjust the format of your data to suit Plotly's requirements. The good news is that Plotly.js is quite flexible and can handle various data structures. 3. Redefining charting function. You'll have to redefine your fetch and display spectrogram and related functions to work with Plotly.js. This would involve creating a Plotly heatmap plot instead of a line chart. 4. Implementation example. A basic Plotly.js heatmap setup for a spectrogram might look something like this. JavaScript plotly.newplot your div-d, z, data matrix, 2D array of your data type heatmap, color scale viridis or any other color scale. Title spectrogram, z-axis title time, y-axis title frequency. Where data matrix is a 2D array with intensity values, z-axis, and time and frequency are your x and y axes. 5. Handling asynchronous data. Ensure that your data fetching and Plotly rendering logic are well handled within the asynchronous flow of your application. 6. Debugging. As always, thoroughly debug each part of the new implementation to catch any issues early. 7. Enhancing user experience. Plotly.js also provides interactive features like zooming, which could enhance the user experience significantly, especially for detailed analyses. This switch will certainly require some rework in your code, but given the requirements for a proper spectrogram display, it seems like a worthwhile investment. It will also open up more possibilities for future data visualization needs in your application.
Well, yeah, it sounds like we we are moving. The bot made a decision. We are moving to Plotly. So there was no luck plotting spectrograms with Chart.js. If anyone have ever managed to do it, do let me know. Now question. So I suspect we'll have to rewrite. Oh, fetch and update. Let's see. Yes, so from this point onward, we have a fetch and update, chat, get labels. So it's refusing to write the full code. Still need the get spectrogram ID. Extract the frequency from column name. We do need that. Yeah, just give me generic stuff. The spectrogram is not currently working. Can we change the code to use Plotly.js for the spectrogram plotting? There should be 4 of them. Yes, so what's his face? Their face, her face. Copilot is writing code. Obviously, that's not it.
Certainly. To transition your spectrogram visualization to Plotly for a more appropriate and detailed representation, you'll need to adjust the fetch and display spectrogram function and any other related parts of your code. Here's a step-by-step guide to modify your existing code to use plotly.js for rendering four
Step by
spectrograms.
step.
1. Include plotly.js. First, make sure to include plotly.js in your HTML file. You can use a CDN for simplicity. HTML, script circle plus, plotly at latest. Now from modify fetch and display spectrogram function. You need to adjust this function to create a heat map with plotly.js instead of using chart.js. Here's a simplified version of how you can do it. JavaScript async function fetch and display spectrogram ID side. Try const response equals await fetch / fetch spectrogram ID equals spectrogram ID and side equals side. If response.ok, throw new error, failed to fetch data response.status. Const data equals await response.json. If data.time array.isArray data.time, console.error, time data is missing or not an array for side. Return const z data equal. This will hold your frequency data. Object keys data for each column name equals. If column name dot starts with side, z data.push data column name, assuming each column is a frequency band. Const plot data equals z data, type heat map, color scale, viridis. Const layout equals title spectrogram side, x-axis title time, y-axis frequency. Plotly.newplot, spectrogram canvas side, plot data layout. Catchall.error, error in fetch and display spectrogram, error. Number 3, HTML changes. Ensure that your HTML has appropriate div elements to display the spectrograms. For instance, HTML div spectrogram canvas lev, spectrogram canvas rlev. Div ID spectrogram canvas LP. Number 4, adjust CSS if needed. Depending on your current CSS, you may need to adjust styles to accommodate Plotly charts. 5, call fetch and display spectrogram for each spectrogram. You'll need to ensure that this function is called for each of the 4 spectrograms after fetching the respective spectrogram ID. Your existing code seems to already be doing this, but make sure it aligns with the new function structure. 6, testing and debugging. After implementing these changes, thoroughly test your application. Check for any console errors and ensure that the spectrograms are rendering as expected. This approach should enable you to transition from chart.js to plotly.js for your spectrograms, providing a more suitable visualization for your EEG data.
Yeah, we need to make sure. Yeah, copy pasting is a skill, isn't it? And let's see. So we have this in update related data. We should have the same. When loading, this should be in initial loading. But this doesn't go here. We actually have a function for this. Something you need. There should be a need data fetch and then a need plot something. Don't think we have that, and that's obviously wrong. It's not updating properly. Fetch Yeah, this one. Yeah, those are the 4. Yeah, so essentially we should have 5 charts. Let's clear the terminal, go to the Flask app script, run it, load it. There's a problem. Console, lots of errors. Fetch and display spectrogram. But why the EEG chart is not loading as well? Let's check that one. Spectrum ID LL. File not found. That's not cool. Assuming the spectrogram ID is correct. Is it safe to assume so? Yeah, that spectrogram ID is a bit weird. Okay, the spectrogram ID was wrong. What's wrong with that? Where did it get that number from? That must be the EEG ID, not spectrum ID. Yes, it's an EEG ID, not spectrogram ID. Silly goose. Fetch spectrogram. Silly little goose. Yeah, this would be in JavaScript. Yeah, we have spectrogram ID. I have a feeling it's stuffed up. No, it is correct. Using spectrogram ID. Back to JavaScript. Spectrogram ID. Okay, it's just called differently. Oops. Okay, we have it called 12 times. A whopping 12 times. Why? Yes, we get a spectrum ID. Yes, that should be correct. We're returning spectrogram ID. Something wrong. For some reason, JavaScript 271. That's the one. Is something wrong? Oh, okay. This might be this may be converted to async function. That's okay. We don't worry about that. Need to make sure the spectrogram ID, oops, is working correctly. Yeah, this get spectrogram ID should have been called before we fetch the spectrogram, that's for sure. There is a problem. The get spectrogram ID should run before fetch spectrogram. No. Text to speech. Am I using the right microphone? Yeah, it should be okay. Should have been obvious. Okay. It's the function. Get spectrum IDs. This is wrong. The function. I won't be able to. I won't be able to fix it myself. Sorry for that. can know what might be wrong. It seems that the fetch spectrogram is trying to load a spectrogram based on EEG ID instead of based on the spectrogram ID. Also, the get spectrogram ID seem to be running after the fetch spectrogram. Shouldn't that be the other way around? Could you fix the code? Yep. Yeah, that initial fetch. Initial data fetch. Is there initial plot as well? I don't think so. Yet spectrogram ID is based on EEG ID. That sounds legit. Let's read it as well.
Certainly. It looks like you've identified two key issues in your code. First, the fetch and display spectrogram function seems to be fetching data based on the EEG ID instead of the spectrogram ID, which could be causing the 404 error. Second, the sequence of fetching the spectrogram ID and then displaying the spectrogram needs adjustment. Let's address these. Half-Slacker 1, correcting the fetching logic for spectrogram data update fetch and display spectrogram to ensure it uses the correct spectrogram ID. This might involve modifying how and when you call this function. 2, adjust the order of function calls. You should ensure that the spectrogram ID is fetched before attempting to fetch and display the spectrogram data. Here's how you can restructure and correct your code. A, updating the fetch and display spectrogram function. Make sure this function is called with the correct spectrogram ID. It looks like you might be calling it with an EEG ID instead. Modify the function signature if necessary to make it clear what type of ID is expected. Tarf B, correcting the order of execution. You need to fetch the spectrogram ID first, then fetch and display the spectrogram. This might involve restructuring the flow of your async calls. Here's a revised approach. JavaScript function initial data fetch. Const EEG ID equals document get element by ID EG value. If EG ID, fetch data and update chart. Get spectrogram ID EEG.
Okay, I don't know why it's reading the code instead of just the comments. The other text-to-speech, well, reads whatever you want, but also it's actually disappeared.
You need to fetch the spectrogram ID first, then fetch and display the spectrogram.
Yeah, this one. And if you do it for the whole response, it won't actually read the code, which is better, but it's need that last bit.
In this revised code, initial data fetch now correctly fetches the spectrogram ID first and then calls fetch and display spectrogram for each of the sides with the fetched ID. Make sure your backend is correctly handling the get_spectrogram_id endpoint and is returning the appropriate spectrogram ID. Also, verify that your fetch_spectrogram endpoint is set up to respond with the correct data when queried with a spectrogram ID. After making these changes, test your application thoroughly to ensure everything is working as expected. Debug any issues that arise, paying close attention to the network requests and responses in the browser's developer console.
I was sure if you don't need to do that. We have chat. We don't need that actually. It's a bit odd because that's still from still coming from chat.js. We are not using chat.js anymore. Pretty sure we're not importing anything, do we? No. Are you actually looking at the code or what? Did I select the whole code? Not sure. We are still trying to figure out how to use GitHub Copilot properly. I mean, a GPT just works in a better way. Do we have? Right, this function does have to change because this is stuff from when we were using chat.js. The chat. Not sure if we still need that my chat. I don't think so. Still being used like 6 times. Why? It's not being used in update chat. Right, it's all commented out, so we can get. Let's just get rid of it. We have update chat.
I see. If you're no longer using chart.js and have transitioned to plotly.js for your spectrogram visualizations, you'll need to remove or modify the code related to chart.js. This includes the update chart function and any other references to chart.js that are no longer needed. Here's what you should do. 1. Remove chart.js dependency. If you're sure you won't be using chart.js at all in your project, you can remove the chart.js script tag from your HTML and also delete any code that initializes or updates chart.js charts. 2. Update the update chart function. Since this function seems to be designed for chart.js, you'll either need to remove it if it's not being used or repurpose it for plotly.js if you still need similar functionality. If you need to update line charts using plotly.js, the approach will be different from chart.js. Here's a simple example of how to use plotly.js to create a line chart. JavaScript function update chart data electrode label. Const labels equals data.mapx index SR. Adjust according to your data structure. Const plot data equals x labels y data, type scatter. For line chart mode lines, name electrode label. Const layout equal title, data for electrode label, x-axis title time, y-axis title amplitude. Plotly.newplot, chart div, plot data, layout. Chart div is the ID of your chart container. In this function, you're assuming data is an array of numerical values and electrode label is a string. Adjust it based on your actual data structure. 3. Remove unnecessary chart.js code. Any code that deals with creating or updating chart.js charts, like main.
Okay. So we have a chart div. What on earth are those? Okay, did another mistake. Well, not a mistake. I mean, I didn't think it changed the plotly. Okay, changed the plotly for everything. That's fine. We can deal with it. I didn't actually think about it. The spectrograms though are still not showing. Oh no, they are. And the data is showing as well. Okay, we are in business. The business of business is business. Okay, we can get oops. Yeah, commenting out in HTML is a pain, isn't it? How more painful can that be? Still using check everything, don't we? To check every bloody thing. Yeah, we're getting rid of that. It's actually working now. So yeah. Should we never use chart.js? I don't know. Is anyone using chart.js? And it's working for them. Plotly seemed to be way better. If the bot would have recommended me to use Plotly to begin with, I wouldn't have even noticed. Okay, so no, lots of spectrogram ID. What's the problem with that? Bad request, why? Missing EEG or sub ID. Pretty sure that the EEG ID does exist. Yes, it's missing in a sub ID. So where are we calling get spectrogram ID with only EEG ID? Should have the sub ID as well, should we? Or not? Are they all the same? I don't know. Well, we shouldn't risk it. Let's see. Column EEG ID. Get spectrogram ID. What's the actual function? Where's this error coming from? we do not. We do have it in the backend. Get spectrogram ID. No, we should fix it. We should have sub ID in it. Just how the data is structured. Yeah, we always should have a sub ID, not just the EEG ID for essentially everything. That's why that error in the backend. By the way, if you haven't checked bionickiosk.com, please do so. There's lots of tools that you might find interesting, and you'll be also supporting the project that way. So hopefully I can make better content. The most recent tool is this annoying thing. Doesn't even fit the screen. This video brought to you by that's not sponsored. But why you have to fix the thing is not fitting the screen. I mean, you can always make it smaller. You can do meditation with this. Should wire it to EEG. Well, actually, it does have 24 particles, each one wired to a different key. There's an explanation there. Should be 24 of them. Originally there were 20. I don't think it's actually mentioned in the description. Bad description. Bad robot who wrote this description. So I don't know, what do you feel like? I don't know, this segment was labeled seizure. It starts a bit like a seizure, but it looks like more like EMG. What do you think? And it just abruptly stops and you have this DC component. Yeah. This is labeled as well as abnormal EEG. This channel has more noise on it. ECG is actually pretty decent looking. Ah, maybe not. No, it's okay. It looks like a low resolution, like low sampling rate. You only have bugger roll samples. But I've seen worse, way worse ECGs with this dataset. Ooh, it's good this one is labeled with AVA, because when you see stuff like this in one of the channels, you can probably guarantee that the other channels will be wrong. Well, not wrong, you know what I mean, bad. Why is it not here? Ah, yeah, it's just clipping. This channel is clipping very badly. Yeah, very bad. Some EEG there potentially, but who cares? It just, yeah, probably it's probably noise. 50 hertz or something. Something's wrong, very wrong with that electrode. So I could ignore it. Question is, how do you automate this thing? Because this dataset is not great. Here you have a DC component like throughout the recording. Also labeled with AVA. Do we have ECG? No ECG. Yeah. Anyway, where are spectrograms? So that the weirdest thing about this dataset is that there's no time window correlation between the raw EEG on the different channels and the spectrograms. Currently they're not loading at all, but where I've seen them just a second ago, there's something. Get spectro. Right, so this one, a get spectrum ID should always have a both EEG ID and sub ID. To fix this code, shall we ask? A get spectrogram should always have both EEG ID and sub ID as inputs. Can you fix the whole thing? Maybe, maybe not. to fix this one. Sometimes these things are links. Most of the time they are not. It's really annoying. Actually meant to modify the JavaScript. So it's the modifying Python, but it does look better. Not sure if it needs the rest of the code. Or not. Maybe it is. Supposedly this is what you're sending to the language model. Sending all of it when selected. Maybe it needs it, maybe not, maybe not. Okay, is it actually using it? It can be an async function, is it? What if I just do Control I update? Are they actually talking to another? They are. Okay. Maybe. Ba-bum. More errors. Yeah, we know why it's happening. Feels like I'm just copy pasting stuff, am I? Well, maybe I am, I don't know. Yeah, I'm never too sure who's developing, you or the bot. You would hope it's both, but not certain. We're having another error 286. Problem with fetch and display. The spectrogram canvas RP is not found. Well, that's because I removed it. I thought they are being added. I'm pretty sure I'm not actually calling them, am I? Have to check. I have to check. By the way, this thing's meant to be interactive, so you can use the chat. I'm live streaming on LinkedIn, Facebook, YouTube, and Twitch just because I can. Because OBS, the streaming software, allows me to do it, because someone very nicely published an add-on for it that allows copying, duplicating your stream. Normally it costs a lot of money with other services to do it. Talking about money, Biomedical is free. Go check it out. There are ads running. Apologies for that. This way you'll be supporting the project. What do you feel like? My brain is currently doing. Yeah, maybe this. By the way, the default. I get this window correctly. Yeah, sometimes it displays well, some other times not so much. And you need to interact with the window first for the sound to play. Funnily enough, there is actually an interesting effect. So when you have, say, one particle, you make it go very fast. When you add another one, sometimes it goes much slower. Yeah, so this one here, for example. And when another particle will bump into it, it will keep being slow like this. Yeah, you saw that? Crazy stuff. No, I don't know, some sort of physical model of particles bouncing. The idea for it, by the way, it is described at the bottom here, is to actually map EEG to this. So instead of reviewing EEG left to right, like you normally will, because this is traditionally how paper in those needle EEG machines was scrolling. The idea is just to review it in a very different way. So you could have, in this case, up to 24 particles, because each is mapped to a different note. It's what's called 2 octaves of notes on a piano. So they each one has a different note when it's bouncing against this blue drum. And then something else, intensity or frequency on its channel, could be mapped to speed. So essentially, if you're having a seizure or something, it will do this and then slow down again. Well, and you could also give them like a direction. So maybe when it's baseline EEG, it will just go random directions, and once you have a certain frequency, it will actually start going clockwise. And when the intensity increases, they will go faster. We can make them bigger. Whatever makes sense. Currently I was thinking, yeah, if you also have like an EEG recorded off your own head and you map it to this, you can then try and relax it. Well, the number of particles is the number of channels. Kind of makes sense. So say you have 24, and then you're trying to relax. Yes, so say currently I feel like that, my brain is active like that. Then you can slow it down a notch to actually try and relax. What do you think? So I'm pretty sure we had the spectrograms there already appearing once, and they did look legit. Obviously, I have to double check, triple check, quadruple check. Yeah, we can bring them back. They still in chat container, I don't know, I don't think so. And just do say that sub ID undefined, what? Getting more and more. Okay, yeah, the spectrograms. So just didn't load them on the get-go. So we have RP, LP, RL, LL, different locations. Looks like there's something there. Yeah, the intensity. How many frequencies do we have? Like 100 different frequencies. Um, meant to be 600 seconds because it's 10 minutes worth of data. So it goes to 330. It's a bit odd. To check that. Otherwise, the spectrum does look legit. And this should be essentially 100 seconds within this 600 seconds. So my guess. Would it be useful? Yeah, this is just how the dataset is. It is a bit odd. It is working, however. Those shots are just scanning forever, are they? So there's something wrong. Those frequencies are not mapped correctly. That seemed to be the continuation of this. So we have LL, RL, let's get rid of that for a sec. Yes, we have time, RL, LP, and the RP this meant to be frequencies. Time ideally should be in a separate variable. I don't think it is at the moment. Should have those frequencies going up to essentially 20 hertz. It's a bit odd. Frequency in hertz. So it is going up to 20 hertz. It's a bit low. Normally EEG is being reviewed. There's something missing, is it? Is it cut off? There's some examples of those example figures. No, this seems to be correct. It's only going up to 20 hertz. It's really odd, but what's the sampling rate? This data set, I keep discovering more and more weird things about this data set. They're all like that, are they? Yep. Yeah, you would expect it to go at least to like 50 hertz or so. Anyway, we'll have to finish up. Let me know if there's any questions or you would like to team up for this competition or something. I don't particularly care about the terms of the competition. I'm primarily looking at this dataset because it's publicly available. And we also hope to release this tool yeah, there's something wrong. Also, spectrogram ID is not being shown. Spectrogram label offset in second is not being shown. I don't know why it's 300 instead of 600. It be 600. It's only plotting half. I suspect it's only plotting half of it. That actually goes from -5 to 5. It's a bit unusual. Anyhow, we'll continue this test next time, fix it up. Hopefully whoever's doing this competition can use it as well, even though it's ending like 20 days. Yeah, good luck to you all. This dataset is not great, that's for sure. I've seen better ones. But yes, I need to fix this. Yeah, this is only showing half of it. Only 5 minutes, should be 10 minutes in there. We'll fix it next time. I'll see you later. There's no questions. Bye.